Okay, let's prove that the limit as x goes to 4 of the square root of x is 2. And again, you're probably tired of hearing me say this, but this is something that we would take for granted in Calc 1. But today we're going to prove it with epsilons and deltas. So as usual, I would recommend some scratch work before we attempt to go and start writing the proof. We know how these proofs go. The first line is just going to say, let epsilon be greater than 0. But what do we have to do after that? We have to choose a delta greater than 0 such that this implies this. In other words, if we assume that absolute value of x minus 4 is between 0 and delta, then we can conclude that the absolute value of f of x minus L, and this is f of x and this is L, is less than epsilon. So how are we going to do that? Typically, and for the examples that we've done so far, there's a little bit of algebraic trickery happening. So let's start with the following observation. We have the difference of two squares. Whoops. There we go. Root x minus 2 times root x plus 2. If I were to multiply those two out, I would get this number squared, which is x, minus this number squared, which is 4. And this gives me a relationship between, so x minus 4, that's this number, and then square root of x minus 2, that's this number, and now I have a way of relating this number to this number. Of course, it involves this other number, which is not something that I really see. Like, I don't see any, up here, I don't see any square root of x plus 2 anywhere. So maybe I'm a little weirded out by that, but let's not be too afraid. This is probably something, yeah, so, okay. Let me not get too far ahead of myself. Here's what I'll write next. I would like to take absolute values around everything, and I can obviously do that. And then also I would like to divide by this. So let me say this equals this over this, and everything's going to have absolute values. Right, those are the same thing. Now, my goal is to reach a conclusion stating that this number is less than epsilon. This number is less than epsilon. I know that this one is less than delta, when I'm writing the proof, I will know that. So maybe I can just write a delta here, and I still don't know what to do with the bottom. But I'll have to figure something out to do with the bottom. This is, we're going to take care of this with a trick that's similar to what we did before. We're just going to assume, very roughly speaking, that x is fairly close to 4. Yeah. How do I say this? Assume that x is fairly close to 4, and I'm being vague when I say fairly close, but let me be less vague. Let me say x is within a distance of 1 of 4. In other words, I'm going to assume that delta is at most 1. That would mean that absolute value of x minus 4, which is less than delta, and then delta is less than or equal to 1, so I can conclude that x minus 4 absolute value is less than 1. And now let me just get a range of x, and I've done this a few times, so hopefully you're comfortable enough. I can take the absolute values off and do that, and then I'll add 4 to everything, so 3. So x is between 3 and 5. So this number that I'm really just trying to get a handle on absolute value of x, or sorry, square root of x plus 2 is, let's see, the smallest it could be is if x was 3, so I would get root 3 plus 2. The biggest this could be is 5, so I would get root 5 plus 2. And let me even, I would like to not even deal with ugly square roots and stuff like that. I want to deal with whole numbers. So let me go ahead and round this one up and this one down just to get two nice whole numbers that I can sort of put this number in between. Square root of 5, that would be between 2 and 3, right? So if I'm rounding this up, I would get 3 plus 2, so 5. Square root of 3, that's between 1 and 2, so if I'm rounding down, I would round down to 1, and then 1 plus 2 is 3. Now that's kind of funny. I got 3, 3, 5, 5, but I think that's a coincidence. Really what I did is I rounded this one down to the nearest integer and this one up to the nearest integer. That's how I got this 3 and this 5. What I can do now is go back to where I was, and now assuming that I have this handle on the denominator, I can say that this is less than, let's see, if I, right, the largest this could be is if I put in 3 for the denominator, right, because the denominator is at least 3. I should not put in 5 for the denominator because delta over 3 is bigger than delta over 5. So what I really wanted is for this to be smaller than epsilon, or actually, let me say less than or equal to epsilon, if we assume, and this is another spot where this is like this scratch work is telling me how to choose my delta. So if we assume that delta is less than or equal to 3 epsilon, and I'm just getting that by, basically I just took this and I solved it for delta. Okay, so let's do the real proof, and before I do it, let me draw like a proper conclusion from the scratch work. What I'm going to do is I'm going to let delta be the min, and we've done this a few times. When I was doing this, I found myself assuming 2 things about delta. I found that it was convenient to assume that delta was less than or equal to 1. So that's going to be one of these things. I also found it necessary to assume that delta was at most 3 epsilon. So I'm going to let delta be the min of those 2 numbers. That way this will be true and this will be true. Okay, but let's do it. Let's do the real proof. Let epsilon be greater than 0, as always. And I'm just going to go ahead and let delta be what we just said right from the beginning. And let me delta is supposed to be positive, so let me write that it's positive. Really, we should be checking that it's positive, but it is. It's the min of two positive numbers. 1 is a positive number, and 3 epsilon is a positive number because epsilon is a positive number. So the choice that we made is indeed a positive number. That's important, but so we should check it, but it's fine, it's true. Now, what I have to do is I have to check that this implies this. So I'm about to say if this. Then, and now I have to say a few things. One of the things I know I have to say is about this number absolute value of x plus 2. I have to run through this this business, and that has to be part of my proof. So let's run through that. So if I have this less than delta, then of course this number is less than 1 because delta is less than or equal to 1. Yeah, delta is less than or equal to 1. So, and now, yeah, maybe I'll go a little bit faster with the algebra than I did in the Scratch work. This is telling me that the distance between x and 4 is less than 1. In other words, like x is within a distance of 1 from 4. So 4 minus 1 is 3, 4 plus 1 is 5. That's really how I get this. That's how to do that the fast way. Now let me talk about the square root of x. The square root of x, and since I'm doing this over again, I kind of did this maybe the long way the first time. Let me go ahead and I will already say square root of x is less than 3 and greater than 1. That is, and this 3 is just if I took the square root of 5 and rounded up. This 1 is if I took the square root of 3 and rounded down, right? So, square root of x plus 2 is between 3 and 5. And this is a positive number anyway. It's between 3 and 5, so actually putting absolute values wouldn't even change anything. Yeah? And that's what I needed. Now I'm ready to go through my Scratch work. I'm going to use this little algebra trick and sort of emulate what I did in the Scratch work, and I'll be all set. Now, this number, which equals this number, is less than, well, the top is less than delta. The bottom I would replace with 3, and again, this inequality goes the right direction. If I want my number on the right to be bigger than this number, then I should replace the denominator with something smaller. I replace the numerator with something bigger than the numerator. I replace the denominator with something smaller than the denominator. And that makes the inequality go the right direction. And this is the step where this is exactly why we made sure that delta was less than or equal to 3 epsilon. So I can write 3 epsilon here over 3, which is epsilon. So this is less than epsilon. There is a strict inequality here, so this number is strictly less than epsilon, as it's supposed to be. So we're good.